All right, up next is use cases for emerging technologies. Drew Appler with Burgess and Niple will be presenting.
Hey, good morning, everybody. Sadly, I will not be presenting on anything you haven't seen today or in the past. Sorry if you were hoping for it. But I will kind of give you guys some good ideas on what to look for when folks like me or folks like BDI come out and talk to you. So this is really more geared towards the agencies and hopefully getting them implementing more useful technologies for what's going on in the future. Today we're going to talk about kind of yesterday's technologies, today's use cases, hopefully tomorrow's solutions, and then we'll close with some fun. This is actually pretty interesting. When I Googled what technology was, there was one common theme that was throughout, and it didn't have anything to do with ones and zeros. It actually came out through knowledge. If you look through there, it's really the practical application of knowledge, especially in particular areas, in our case, engineering and bridges. So what does that mean for us in the daily sense? We're looking for using the knowledge we have on our bridges to make more informed decisions for the future. So that's really what we're hoping for. You may or may not have seen this product. This is actually the common bell curve that we've all remember from college with the solid C right there in the middle. Yeah, everyone hates the person on the right, and usually you're the person on the left. No, I'm just kidding. This is actually product adoption curve, which is pretty common within the technology industry. It's broken up pretty much 10, 30, 20, 30, 10. With on the left-hand side there, the tech enthusiasts. This is pretty much your cousin who has the latest technology. Before you even know it's a thing, I think Bitcoin in 2009 would be considered this. More innovative person. The visionaries are early adopters, early majority and then late majority, and then obviously the person who's the lagger. That's the person who still wants the flip phone. I know there's a couple people out there that they'll have to implement an iPhone at some point, but sadly they don't really want to. So if Henry Ford asked people what they wanted, what would they say? Just a faster horse. Well, that picture kind of speaks to it. I think the last time we saw that was on some Netflix show. But in reality, we look through and that horse has turned into the internal combustion engine. That internal combustion engine has really turned into what Elon Musk's next dream of a car with batteries. So it's really kind of pushing forward. Now we look at it more on the sense of what we do on every day. I think we talked yesterday, and somebody had said ASD is the best. Everybody loves ASD because those bridges just stand up. ASD is kind of the abacus of the current day. Well, now we get into LRFD, and we have the tried and true HP calculator. I think everybody loves it. You either love it or hate it. And then you look forward, and now we have our computers. Our computers do most of the computing today for us, so we can't really say why a system or a number is red, but the engineering, there's an old adage I say, when I come out of engineering school, a monkey can do my job, but the difference is I can tell you why that number's red and how to fix that number, and then the calculation and the equation behind it. So. Today we're going to talk about three main areas: data collection methods, the data output methods, and then ultimately using that data. So data collection methods, we've talked about it a number of times today, even this morning, whether it's Mike and doing some other sonar, multi-beam versus single beam. That data collection method for the top side is generally an iPad for us. We've been using iPads for decades, or yeah, I guess it is now technically decades since they came out in 2010. Drones and photogrammetry is kind of the newer phase. LiDAR is there, and it's implemented on very specific cases. Now when we look at data outputs, we're looking at the very standard PDF. Everyone loves PDFs. They're easy to use. The more advancing into that is the digital twin. What you can do with the digital twin is really great. And then AR and VR, augmented reality, virtual reality, is still out there. We're hoping for it to kind of take off, but really its development is a little slowed. And then what do we do with this data after we have it? I mean, we have a PDF, we have these digital twins. When we really want to take a look at it, we want to have these artificial intelligence programs that we've all heard, ChatGPT, come out and have these glorious conversations and esoteric conversations about what the world will be. Well, how does that fit into what we do on a regular basis when it comes to bridges? So again, iPads are kind of the old hat. I'm going to start with the low-hanging fruit here. iPads came out in 2010. We use them. They're very useful. They allow us to immediately take data from the field and turn it into a table. because engineers love tables, right? And it's generally what everybody here loves to look at and scroll through and create pivot tables. Next, we move into drones. I personally find them very useful. I've been working with them since before 2016, before the real Part 107 came out, and I've seen really the industry change from very hesitant to being more on board with it. I think a handful of presentations over the last couple conferences really have been about drones and their usefulness. I think the biggest thing for me when I look at it when it comes to drones, and again, this is low-hanging fruit, drones provide an excellent point of view. I think we've all seen high-mast light towers up until about 2, 3, 4, 5 years ago. This is the common way of inspecting it. We either lower the tower down, or we have a spotting scope, or we have some binoculars and maybe a high zoom camera. Well, now we're able to move forward and say, all right, this is what we're actually looking at. We can get that high zoom camera up into its airspace and to really look at not only the top connection points, but also the slip joints that are there that are common failure points. Next step, drones utilizing a good photogrammetry software really have allowed us to provide a more accurate load rating analysis. This is a particular gusset plate measurement that we utilized for load rating. We used to have to throw on a handful of different scales, and now we go through and the drone will create its own photogrammetric output and allow us to get really accurate models. Prior to this, it was very difficult and cumbersome climbing up there. A lot of this is done at heights, so you're out on SPRAD access, rope climbing. Nobody likes doing that. It's difficult to collect that data. Now we can get out there and collect the data, and so we provide a more accurate data to you, the owners, as well as the ridership going over the bridge to ensure that it's actually safe. Now we'll start looking at kind of some specifics and where the drones and software have really kind of come to see a lot of fruition. Today's big push this is not a bridge, but this is very apropos to our situation. We always want to understand very specific ideas about what our bridge looked like. And what's the saying, a picture's worth 1,000 words? Well, anytime you go outside anybody's office, any engineer, they're going to want to see a word, or they're going to want to see a picture. They're not going to see words or tables. They want to understand at a fine detail specific cases. In this particular case, we went through and were able to map this whole entire wastewater treatment facility. Not only allowed us to map and understand what was there, allowed the owner to really have a good idea on what the current conditions are for the systems that they don't always see. You're not up on the roof every day, so when you're out there climbing around, you're kind of laser focused on one particular area, so we want to make sure we have more things pushing than just one person's eyes. That'll be a common theme throughout this and the future slides. For me is I want to remove this inspector bias. I want to use technology to say, okay, this is now the actual case, not just someone's interpretation of what the data is. Today we've got a LiDAR. It is light emitting distance and ranging, just like sonar. And again, it's been talked about in the past. RDOT did a fantastic case of some LiDAR imaging a couple conferences ago. But in this particular case, I want to take a second to say this is more going to be on the practical application of knowledge. Given this particular case, well, let's just go ahead and fast forward here, clean up this data. We actually had this case, this was where we utilized one of our terrestrial-based LiDAR scanners to help evaluate some flooding concerns. Down in Florida, you might know there's beaches, people love the beaches. You don't see basements that often, though. So this owner, adjacent to a DOT roadway, decided to build an underground parking facility, and then promptly said that the DOT roadway was flooding the underground parking facility. And they said, okay, well, that would be hard, and you go out there, even with traditional survey, we could find out the answer. But just like everybody else, try finding a survey who can get out there on a moment's notice. It doesn't necessarily need to be down to the millimeter accurate. You just want to get a better picture of what's happening so that you can turn around and turn that to your owner and say, this is what we see is what's actually looking like out there. From that particular case, you'll see the Coca-Cola truck there. And this is actually the cross-section that we were able to take from that LiDAR scan Down here on the right-hand side is the lower drop down for the lower level, and then above it just happens to be an upper level of that parking garage. Well, if you draw a line directly across here from that high point, which would be considered the, I guess, crest of where the wave or the water would have to be, the water would actually have to be halfway into the roadway, the second lane of the roadway, so it's a 4-lane roadway. And yeah, that never happened. No complaints were ever mentioned. So we were able to determine that actually it was the top deck of the parking garage that was flooding the bottom deck. Go figure. This is the next particular case. This is a local MSE wall that we took out, a scanner, and we could tell that there was a problem. In fact, the owner knew there was a problem here at this location, or else we wouldn't have been called out. But if you look over on the left-hand side here, you can actually see the fill that was starting to evacuate from behind the wall. So we knew the location of the deficiency. But the issue we ran into was we couldn't tell the extent of it. This was an MSE wall, and it was highly textured. So putting a 4-foot level on a 5-foot panel wouldn't really help much. Even a 10-foot level wouldn't have done much. So when we actually took a look at this, we were able to determine that it was about 30 foot of paneling that was actually starting to bulge out due to loss of fill. And to kind of add insult to injury, this was on a 3,000-foot radius. So it wasn't even if we were able to get a straight laser line. Really, this was the only way we were able to determine what is a feasible limits to be repaired. When we take a look at the section, you can actually tell that wall on the top side is bowing outward. Again, we knew that was happening. We could visually see it, but it wasn't the extent. And again, this panel's differential was about 1.5 to 2 inches. At the easiest case, and the worst case right here turned to be closer to 3 to 4. This is a local toll facility that we utilized the scanner on. Again, and we're just looking at collecting data points. Ones and zeros were said earlier. And this particular case, they were transitioning to a cashless system. So these toll facilities really were just glorified storage units. But the roadway underneath it was still actively tolled. So closing down that roadway would require us to take money away from the department. That's not something we wanted to do. So setting up these systems, we were able to determine that, again, we were called out because something seemed off, but they didn't want to necessarily sound the alarm bells before we knew what was actually going on, or was it just an optical illusion. After we set up these scan points around, we determined in very short order that there was actually a 3.5-inch deformation of that fascia beam. And at that point, then we said, okay, well, let's really do something about this. Now we know it's not an issue, or now we know it's an issue. Let's really see what we're able to do. But one thing you can kind of tell, there's a big toll sign right here. When you create LiDAR point clouds, just like Mike had said earlier, you're able to pick the plane that you want to evaluate. You're just putting in a point in an XYZ coordinate. And when you do that, you really know exactly what's going on at that point, and then you're able to create a long-term plan coming out with successive inspections. And I say everything's in an XYZ coordinate because this next one was very specific. In the lower left-hand corner of this picture is what we call Scioto Downs. I don't know if I'm supposed to say that or not, but everything's fine. So Scioto Downs penthouse. We got a call in 2021 for evaluating this structure. The old maintenance person had been there for 20, 30 years, long enough for him to say, something seems off. I feel like the joint between this building right here and its adjacent building has gotten smaller over the last couple of years. And even with traditional survey technologies, how would you evaluate that? Stick a plumb bob on each column, survey one point, and then go around to the other side and try to understand that. Again, we're looking for speed and data. We want a lot of ones and zeros, and we can start crunching it. So after we looked at it, this penthouse is built on 8 columns. They're about 24 inches in diameter, spaced around the exterior. And after we went through and scanned, we were able to determine that, in fact, these columns weren't moving in one succinct manner. They actually were moving in a bunch of different manners, in different ways, between 0.01 of a foot and 2 inches at its max. So they weren't all moving in one direction. So sorry, old man, maintenance was wrong in this case, but thankfully it saved them a lot of time and money and hassle and headache because we were able to give them definitively that nothing was going on with this structure and they could open it back up for race season. Now, we all have culverts. Some are smaller, some are bigger. This particular case was actually a culvert lining process. We've used these offset elliptical culverts in a number of states, and when we start looking at it, they start deflecting. When I started evaluating this, I really wasn't expecting this much deflection to occur over the time. I think everybody's water line, if you're able to walk through and hit your hammer through the water line, that's a CS4. You probably should sit down and have some conversations with the owner. This particular case, they knew they had issues. So we wanted to come back and do the analysis. We had the as-built original design, what it looked like when the plans went in. Well, now we needed to know what it looked like throughout the whole entire line, the whole entire culvert, and then figure out what we're able to design for a future lining. So in this particular case, we were able to easily understand exactly what our limitations were throughout the entire culvert, not just at individual points, to help aid in construction with minimal information. Now, we all know these companies. Really? Okay, yeah, you're right. Okay, good. Nope, I'll get going. We all know these companies. These companies, 10, 15 years ago, we accepted the terms of service happily to use their products. Now, fast forward 10, 15 years ago, this data that they've been using based on our terms of service agreement has made them a lot of money, and now we're all upset about that. Well, now we fast forward to today's technologies, and I start saying we've collected our data. We've started digitizing all of our information. We've collected it. Every state here has to collect it. How are we going to use it moving forward? How are we going to create these digital twins? And again, this is not a specific, every bridge needs a twin, but very specifically, the bridges that matter the most probably should have something more tracking behind it. So we know, I'm going to just speed through here. These are some digital twins that we're working on currently. It helps define issues, both from the pre-inspection as well as post-inspection, document, delineate any issues we may have. It allows us to annotate items very easily and quickly. We're not limited to just vertical faces. Underside and fascias are easily implemented and tracked across the year or across multiple years should we move forward in that. And then the best part for me probably is really going to be what do we do with this data? Now that we have this in 3D form, or in this particular case 2D form, how do we implement this into repair plans? How can we have this aid quick repair documents? We could take this data and take a cut sheet of it and splice it directly onto the next document for any repair plan or maintenance crews to look at. Again, a picture's worth 1,000 words. Now moving forward, with the increased detail, we're able to actually start taking more and more use of that data. Take these pictures and turn them into ones and zeros. Companies are able to understand what cracks are when it comes to photos. Artificial intelligence is definitely one of the key buzzwords that everybody says. ChatGPT is outside the industry, inside the industry. We've got a number of programs to help aid in not just the inspection, but also kind of finding those cracks. Again, when you have an inspector out there and they're dead focused over here and you look off to your right, I think if you have the blinkers on, looking at this crack, you can't find this crack over here. Again, I want to remove the inspector bias, and I want to allow that to be put into the hands of the engineer or the person who's working on the repair project, not just the inspector who says, is that an 8-inch crack? Or maybe it's a 10-inch crack, I don't know. Was the inspector's eye calibrated that day? Did he have a second cup of coffee or not? So again, these digital twins, when you start implementing the AI, you can have both crack detection as well as non-crack detection. Again, nothing I've said today is all that earth-shattering, but these are just specific use cases that we're trying to get out and say these are very usable for today's society and today's inventory. Now, let's see. This is actually one of the first options. This is the country's first urban via ferrata that we flew and to actually help determine the rock quality along possible routes. And if you see, this is, I would say, probably the best scan that I've seen. It's extremely detailed, and it's probably most ideal based on the fact that it's non-geometric, non-repeating, vertical-faced structure. So when we go through and look at this, we could tell in clear detail what quality of rock we have. Now pushing into kind of what the future holds and getting this data out there. Augmented reality, virtual reality have been around for a while. This particular case allows us to see more than just what's right in front of our eyes. Allow us to have PDF files pulled up directly in our field of vision so we can compare apples to apples without taking our eye off and doing this. We can just look back and forth, left and right. Again, here's a virtual reality Midas model that we've created. I'm going to go over that. So these are kind of the next step when it comes to artificial intelligence. These companies have created products that allow us to utilize data as ones and zeros, but ultimately it comes back to making the engineer aware of what's out there. It doesn't ever replace the engineer. Now I can definitely say I'm happy. The engineers will not be replaced, at least hopefully not in my lifetime. But when we look at it, we really want to understand what the value is here for the future, for us to really speed up inspections. Nobody wants to keep paying more and more and more for inspections, so let's make more use of our data and more use of the time that we do spend. In closing, again, let's come back to this adoption curve and where we're at with some technologies, and then I'll wrap it up. iPads, sorry, I feel like iPads are kind of back with the laggards. That's just my personal opinion. Drones, they're fantastic tools. They're being repurposed in a number of different ways, but they really are kind of in the late majority. If you don't have a fleet of drones, you're kind of looked at kind of side like, why aren't you flying yet? 3D models, digital twins are still kind of on the upswing. We want to make sure, and that this is one of the conversations I want to have, is I want to push these technologies to really implement them and understand what their limitations are, what the value that some of the states see in them. And then ultimately, artificial intelligence. It's coming, whether we have a choice or whether we want it to happen or not. So when we look at it, I think in reality, the ones and zeros will ultimately take over, but I think we as engineers really need to drive and guide that program and that question and say, all right, this is where we're taking it. And with that, I'll end quickly before I get kicked again. Any questions? Thank you very much.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.